Probability of compound events. A compound event is two or more simple events. An independent event is when the second event is not affected by the first event. And a dependent event is when the second event is affected by the first event. In a moment, we're going to talk about the difference between independent and dependent events. But the good news is that to solve, you do it the same way, whether it's independent or dependent. So you're going to see probability of A and B, meaning the probability of the first event and then the probability of the second event. And the way you solve that, it's the probability of the first event times the probability of the second event. Sometimes you'll see and, or sometimes you'll see the word then. Sometimes you'll see the word and then. All means the same. Take the probability of the first event and multiply it by the probability of the second event. So it's very important that you're taking the time to set up the question for yourself and writing P and then whatever the two events are and separating them with the word and or then. So we're going to come up with a cheat sheet of independent events. Remember, independent is when the second event is not affected by the first event. So if you have two number cubes and you toss them, it does not matter what you get on one of the number cubes. It has no effect on what happens on the second number cube. You spin a spinner. Whether you're spinning the same spinner multiple times or you're spinning two different spinners, one spin does not affect the next spin. Tossing coins, whether it's the same coin over and over or tossing multiple coins, the one toss does not affect what you get on the next toss. Picking an item and replacing it. That item could be marbles, it could be cards, whatever it may be. If you pick up an item, put it back, and then pick out the second item, it is independent. You have not changed anything in that situation. Any combination of these independent events is also considered independent events. So tossing a number cube and spinning a spinner, one has no effect on the other. Tossing a number cube, tossing a coin, no effect. Now with dependent events, there's really only one event, and that is picking an item and not replacing it. So that's if you are picking items, whether it's marbles or coins or cards, whatever it may be, and if you pick the first thing and do not put it back before you make the second pick, you have changed what you could select from, and your outcomes will then be different. So that is a dependent event. All right, so looking at this question, find the probability that a coin lands on tails and a number cube lands on 5. So this is a compound event. Two things are happening: tossing a coin and tossing a number cube. So we're trying to find the probability of tails and getting a 5 on the number cube. This is going to be an independent event. Tossing the coin has no effect on what you get on the number cube. So the probability of getting tails on a number cube, the probability of getting tails on a coin is 1 out of 2. And the probability of getting 5 on a number cube is 1 out of 6. And tells you to multiply. We cannot simplify anything, so we're just going to multiply numerators, multiply denominators. So the probability is 1 out of 20. In our next situation, we are going to use some marbles. There are 5 yellow, 1 purple, 3 green, and 3 red marbles. I have them here for you to see as well. Find the probability that a purple and then a red marble is selected if the first marble is replaced. So this is going to be another independent event because we are replacing our first marble. So probability of purple So looking at our sample space, the probability of getting purple, there's 1 purple out of 12. Assume that you get the purple marble, but then you have to replace it. And now we make the second pick of red. So there are 1, 2, 3 red out of 12. Then tells us to multiply. We can simplify 3/12, and that is 1/4. And now we can multiply 1 times 1, 1, 12 times 4, 48. So the probability in this situation of getting a purple and then a red marble is 1 out of 48. Find the probability that a purple and then a red marble is selected if the first marble is not replaced. Not replacing makes this a dependent event. So probability purple, then red. You can see the setup looks exactly the same as the question above, but the difference is this time when we get the purple, which is still 1 out of 12, assume you get it and you do not put it back. So on the next pick, there are 3 red, but now only 11 marbles to choose from. So what I have has been affected. Then means to multiply. I can cross cancel the 3 and the 12. So the probability of getting a purple and then a red if the first marble is not replaced is 1 out of 44. Find the probability of selecting 2 green marbles in a row if the first marble is not replaced. Okay, we're not replacing it, so that tells us that this is dependent. Remember, when we write our question for ourselves, P, we're not going to write 2 green marbles. That's not going to help us. We want to write it with the word then in between. So what's happening here? We have to get a green and then another green. So we're going to write it as green, then green. All right, so on the first pick, we have 3 out of 12 marbles that are green. Assume that you get a green marble, just one, because you're just picking one. Assume that you get it. On the second pick now, there's only 2 green marbles out of 11 total. Then means to multiply. So I can cross cancel the 2 and the 12, 6, and then the 3 over 6 is a half. So when you multiply that, you're going to get 1 out of 22. So 2 green marbles in a row, if the first marble is not replaced, is 1 out of 22. And last question, find the probability of selecting 2 green marbles if the first marble is replaced. So if we're replacing it, it is independent. Let's go ahead and start with all of our original marbles. Again, 2 green in a row. Do not write 2 green marbles. Write green, then green. So on the first pick, 3 of them are green out of 12. Pick a green marble, but you put it back. So on the second pick, there are still 3 green out of 12 marbles. Simplify. Both of these become 1/4. And when you multiply, the probability of 2 green in a row, if the first marble is replaced, is 1 out of 16.